Okay, in this video we're going to look at finding limits algebraically. So when we look to find limits algebraically, sometimes by the way this is called analytically, we're not looking at a graph, we're not looking at a table. So the first step here that you want to always apply is direct substitution. So if we're trying to find, for example, the limit of the function x squared plus 1 as x approaches 2, you're simply going to take this 2 and you're going to drop it in wherever you see an x. So if we do that in this situation, we get a nice clean easy answer of 5. It's that easy. You're done. Let's look at another one. Okay, here's another example. Now we have a rational function. We have the limit as x approaches 3, and remember we are approaching 3 from each direction. So, and by the way, it doesn't even matter which direction you approach it. If it were from the left, from the right, or both directions, it would not matter. You're still going to apply direct substitution. So if I plug my 3 into what I have here, 3 squared minus 9, I'm going to have a 0 up top, and then in my denominator, 3 plus 3, we're going to get 6. So 0 over 6, that is a real number. It's not undefined. That is 0. So 0 is our answer. Okay, here's another one. This time we have a trig function. We have 8 sine of x. We're trying to find the limit as x approaches pi over 6. Don't freak out because we don't have a nice clean integer for our x value. It's pi over 6. So we're going to simply plug that in. So we end up with 8 times the sine of pi over 6. Now this is in radians, so the sine of pi over 6 is the same as the sine of 30, which recall, it's one of the big three you should have memorized. That's 1/2. So this is 8 times 1/2, or 4. So that would be our limit. Let's look at another one. Okay, in this example, x is approaching e. Remember, e is about 2.718. It's a number. So when we do our direct substitution here, we end up with the natural log of e plus e squared plus 2. Now the natural log of e, careful, it's not 0. We know that they are inverses of one another. They're going to offset one another, but yet are left with 1 when you do that. So our final answer here would be 3 plus e squared. Okay, e squared is nice and exact. We leave it just the way it is. If it were multiple choice, that's what you would see. And let's look at one more example. Okay, in our last example here, we have the limit as x approaches 10. You see 3x plus 2, that whole quantity raised to the 2/5. So we drop in our 10 for x, and we end up with 32 raised to the 2/5. Now this is certainly fair game for a no calculator question. A couple different ways of approaching this. One is you can recall that a fractional power is going to be a radical. 32 is underneath. The denominator of 5 is the root number, and then the numerator of 2 would become the square. From there, you can either do 32 squared first and then take the 5th root, which obviously is going to be a monster if you were trying to do that without a calculator. It's obviously a lot easier to do the 5th root of 32 first, get 2, because we know that 2 to the 5th is 32, so we're left with 2 squared, or 4. Another method, if you don't like that, would be to go back to your 32 to the 2/5 and to say, okay, 32 I know is 2 to the 5th, and then we still have this power of 2 over 5. Well, from there, a power to a power, we multiply. Notice these 5s would cancel. You're left with 2 squared, which of course is the same as what we got before. So our limit would be 4.